Hello and welcome. This is a quick video for C3. Now, I have done this topic and I'm not 100% sure if I covered this. What I'm going to do today is I'm going to prove to you, obviously as the title suggests, that R cos x take A equals A cos x plus B sin x. Now, them A's and B's can be any given values. I'm just going to prove the identities. So your A equals your, your tan inverse of your B over big A, and then your R equals your square root of A squared plus B squared, Pythagoras to you and me. So obviously this could be anything. Now, so the A's and B's could be anything. So R times cos x take A equals A cos x plus B sin x. Now, obviously, this rule, I should stress, works for anything. In terms of, you could have, you could be talking about negative cos x plus A, which obviously give you a negative here, because in cos the signs change, but in sines the signs stay the same. Pretty good that. So, I'm going to be focusing on this one because, well, I can. Okay, so as I said, I've got an agenda for today. So as for my last few videos, I'm going to go through the identities, picking out some major bits that I'm not going to give away just yet, otherwise I'd give away the whole video. Focusing on this cos x take A bit mainly, that's the quite important bit to get your head around. And then I'll be going on to just demonstrating, going through the proving the rules, and just a few tips as we go along the way. So not too much to give away at the start of this video, because as I said, this video is just a quick summary of C3. I'm not sure if I filled it in, or I'd like to do a whole video on it, that's why I've got this. Okay, so I mentioned just then, you need to focus on this cos x take A. Now, obviously A being a value and x being a value, you could say, oh, we'll just take them away. Well, relating to our idea of our addition formula, which is what we're actually going to input. So, your cos A plus or minus B, if you remember, that was equal to your cos A, cos B. So you have this in your formula book, plus or minus, your sin A, sin B. Okay, so hopefully you should remember that from your Core 3 studies. So see, I'm doing this from a Core 4 perspective, but this is still Core 3, so I'm on Core 4, but don't worry about this. I mean, just should have shut up then. So, how can we input this? Sorry, how can we input this into that? Well, instead of using A and B, what we're going to use is X and A. And what we're going to do is we're going to times all of that in relation to, so when we input this equation into that, using the given values, we're going to times it by R, and then we'll simplify it down and get some ideas of how we can work out the rest of the formula. But that's the basis of this. Okay, so what I'm going to do at the top is I'm just going to write out what A and B actually are, so we can see where we're going with this. So A is equal to X, and your B is equal to your A. If that doesn't make sense at all, I know, we'll go along with it. So if we continue this, so R times, no, we're going to put this in, actually put it in square brackets. Serious stuff this. That's how serious it is, square brackets. Times. Now, I'm not going to put cos A plus minus B, I'm just going to go straight to the second half of the formula, because that's what it's equal to and that's what we want. So, cos of A, which is X, so cos X, cos A. Now this is a plus, sorry, this is a minus, we're going to make it plus. So it's plus sin X, sin A. And obviously you could write equals that, but I'm not going to because I'm lazy. Now, what we should do is expand this out. Now we're not going to do cos squared x A. Obviously it's R times cos x cos A plus R times sin x sin A. So we're going to write that in that format. So R cos x, cos A, plus r sine x sine a. Okay, so what do we do with that? Well, we could just draw a smiley face there, but we're not going to, because this is maths and maths people aren't fun, hence why I'm teaching the video. This is a bit about me actually. Okay, so what can we do with that? Oh, sorry. I just get out of the way while I cough my guts out. Okay, so what we need to do now is, this is as far as we can go really, without doing something else. We need to relate this to the original formula that we've got up here. Now, what we've got here is basically an expansion of this. So we could write this as equal to your a cos x plus b sin x. Now, what we need to look at is our factors of a and b in terms of this side of the equation. So what I mean by that, this is the tricky bit to get your head around. So if we look, this is a, so all this is the a part of the equation, and all this is the b part of the equation. Now, we need to look at the factors. So basically, what do you times cos x by on the a side? So for this, what did we times a by to get this? Now, we times a by, this a cos x, sorry, we times that by r cos a. So a is equal to the factors that we times it by. So r cos a, because we've got cos x here, that's why we're not including it. So a is equal to r cos a. Right. Same for b. So if we work on this philosophy for b, just bear with me and I'll explain why we're using this philosophy in a minute. Right. So use the same philosophy. So b sin x. What do we times sin x by to get r sin x sin a? We times it by r sin a. So that's going to be r sin a for b. Right, so hopefully it's making a little bit of sense. Now, what we need to do is we need to be able to, because obviously we don't just want to, we want to put these in a more organised fashion. So we need to make cos a and sin a as subject to these two equations. So we could say a over r equals cos a. And then we could say for this one, b over r equals sin a. Basically, I've not introduced anything new, just rearranged these equations. So fun times. Okay, so once that's out of the way, the tricky bit, as I said, is getting your head around all this rubbish. Basically, just looking at the factor, saying, a, what do we have to times a by to get, what do we times a, so a cos x, what do we have to times that by to get your r cos a, and we had to times by r cos a, and then we do the same for b, say, what do we times b sin x by to get r sin x sin a. So for the purposes of this experiment, you could just ignore the a's and the b's, but we're just looking at the factors of a's and b's. So what do you have to times cos x by to get r cos x cos a? What do you have to times sin x by to get your r sin x sin a? You have to times it by r sin a for b, and r cos a for a, if that makes sense. And then we just rearrange them and we've got some identities here. Now, what we did, I'm not sure how I'm going to put this in my playlists, but just a quick reminder or heads up if you haven't done the topic yet, what we do something called further trigonometry. I think it's listed as one of my videos in the playlist. And in further trigonometry, what we did was we used this addition formula. So I'm assuming you actually do know this, otherwise you would have just been completely stumped going, what is that lunatic who has no life going on about? Well, I can't answer the why do I have no life part of the question, but in further trigonometry, what we used triangles, scale triangles. So we used equilateral triangles and worked out tan of 6 over 8 or whatnot, you know, for example, in terms of the triangles without using a calculator. So we're going to apply the same philosophy here, because again, this is proof, so we're not using a calculator. So we can't, I mean, we could simply substitute in a calculator at this point, but you know, it wouldn't be very helpful to us. So let's continue with this idea. so what we're going to draw is I'm just going to draw a basic right angle triangle. I'm going to take it down a little bit, a notch from our current level. Okay, and then we have an angle. I'm going to call it X. We have a hypotenuse, R. Now, actually, kind of give it away a bit. So, cos A, if you remember your soccer tower, right? If we're going to put this, obviously X, A being the angle, sorry. So you could put A instead of X there, but I'm just going to leave it as X because that is a given angle. How would you put this in terms of the triangle if you were using a further trigonometry idea? So I'll just give you a second if you know what I'm on about to have a go at that. Again, if you're in my class, you will know what I'm on about because we need to go through this exact method. I'm just doing it for obviously this is all my idea by the way, from other people. So just give you a second to pause the video now, so you can have a quick go yourself if you want to try and put them two equations into the form of a triangle so we can work it out without a calculator like we did in further trigonometry. Okay, so hopefully you've had a go. Now, cos, if you remember your soccer tower, so tower, so cosine is adjacent over hypotenuse, and because that's A over R, adjacent over hypotenuse, adjacent is here, R, and then if we apply the same method, it'd be that. So you got R, B, and A, and you look at your X there. Alright? So now to get X, assuming we don't know R, by the way, which you generally don't, because that's the whole point of working this out, we don't know R, how are we going to find X? Well, the tan inverse of B over A is equal to X, or little a, which is, sorry, that's confusing actually. Change this, so it's big A and little a is the angle, and then that's going to give you the angle, which if you look in your formula block is exactly the formula for the angle. Now, how do we get R? Well, Pythagoras. So your R is equal to your square root of A squared plus B squared. So that's what your R is there, okay? So hopefully that makes some kind of logical sense to you. Right, so that's the two formulas done and dusted. So they're the two identities we really needed to focus on. So as I said, hopefully that's made some kind of sense. It's a lot easier than the rest of the stuff we've been doing in C3, but I hope it's been of some use, and any comments or anything, just let me know. Or anything you didn't get in that video I just went through, again, just let me know or tell me to shut up. Wouldn't be too much appreciated. But, as again, we'll see you in the next video. Thanks for watching. Thumbs up, that's one, pretty good.